You're welcome to my YouTube channel. Once again, remember to subscribe, like, share, and also click on the notification button for more updates on my on physics and mathematics lover channels. So today we're going to be discussing about what we call physics. So what is physics? Those are like for beginners, for SS1 students. So what is physics? Physics was formerly called natural philosophy. It is concerned with these aspects of nature which can be understood in a fundamental way in terms of elementary principles and laws in the course of time. The most basic parts of physics are mechanics and field theory. So like those are the basic parts of physics. So they are called mechanics and field theory. What are mechanics? Mechanics is concerned with the motion of particles or bodies under the action of given forces, while physics of field is concerned with the Virginia, nature and properties of gravitational, electromagnetic, nucleus and other force field. So taken together, mechanics and field theory constitute the most fundamental approach to an understanding of natural phenomena which science offers. So now we're moving to units. We have two types of units: derived and fundamental units. So fundamental units, what are fundamental units? You know, first let me explain what is unit. In physics, or any okay, let's take mathematics for example. We used to have something, maybe like now we are like doing something, maybe something like area, length, breadth, something like that. We used to have like something we just put at the back. So the unit of length is what? Meter. When we are doing something like volume, we have something we call meter cube. That is at the end of like your final answer, you say so, yeah, so it is 1,000 meter cube. So that meter cube there is the unit. So in physics we also make use of something like that. So then, but in physics we have two, it is divided. In maths they will not tell you that one, but in physics you have to know it. So we have fundamental unit. So let me say fundamental units are the acknowledged standard unit or measures in which measurement is made. That means they are the one that are generally accepted all over the world. The one like the original unit for any thing you want to like fit or anything. So examples, we have meter as the unit of length, as I said earlier, kilogram as the unit of mass, second as the unit of time, ampere as the unit of current, kelvin as the unit of temperature, and so on and so forth. So okay, for example, let's take second as the unit of time. Second is the smallest unit in time before you cannot have a minute or an hour. So without a second you can't have a minute, without a minute you can't have a hour. When you say 60 seconds make how many minutes? 1 minute. So that's the way fundamental units are. They are we go to derived unit. Derived units are new unit or fundamental units derived from fundamental unit. Derived units are new units that are formed from like the combination of two units or two fundamental units. For example, let's take the unit of acceleration. The unit of acceleration is meter per second squares rather. Velocity is meter per second. Volume is meter cube, like I said earlier. Okay, let's take volume for example. The unit for length is meter. Then an area is the square of that length. That we have area is the unit of area is meter square. Then you now have volume. Volume is now the cube. So volume is like say between fundamental and derived unit. So now let's go to differences between fundamental and derived units. Fundamental units, they are standard units of measurement. Derived units, they are not standard units of measurement. Number two, they are generally accepted all over the world. That is for fundamental units. Like I said earlier, they are generally accepted all over the world, and derived units, not all are generally accepted all over the world. They form the basis of measurement. That's for fundamental units. Then for derived, they are not the basis of measurement. Number four, they are accepted by international organizations, while derived units, through them, they are not really accepted internationally. So we have fundamental quantities. That is another aspect. Fundamental quantities, note, fundamental quantities is different from fundamental units. So fundamental quantities are the basic quantities that provide the standard unit of measurement. So unit is what we use in representing the quantities. Examples of quantities are length, mass, time, temperature, current, and luminous intensity. So now, derived quantities. Examples of derived quantities are power, pressure, density, and work. So let's go to differences between fundamental and derived quantities. Note, I'm not talking about units, quantities. Number one, they are generally accepted. That's for fundamental, while derived and they are not just generally accepted. Number two, for fundamental, they are based on international system, while for derived, they are not, they are formulated from international system. Number three, fundamental quantities can stand on alone, while derived quantities can stand alone. Number four, they are basic units of measurement, and derived units, they are not basic units of measurement. So that's going to be all for today. See you see you in our next YouTube video. Like, subscribe, share, and also click the notification button to get updated. Thanks.